Real life problems. Length, area, volume. Differentiation. Problem 2. A farmer wants to build a rectangular shape pen with length x meter and width y meter. The farmer has 20 meter of fencing in total and wants the area inside the pen to be as large as possible. How long should each side of the pen be? And what will the area inside the pen be? Here's the pen, and area equals length times width. In this case, the length is x meter and the width is y meters, meters squared. That's x times y meters squared. So let's work out the total perimeter of the pen. Will be equal to, well, this is y and this is x, so that will be 2x plus 2y. And that should be equal to 20 meters. But the area equals xy. So if I rearrange this and make y the subject, y into here, 2y equals 20 minus 2x. Y equals 20 minus 2x over 2. Y equals 2 into bracket 10 minus x over 2. I've taken 2 as a common factor from the numerator, cancel 2, and y equals 10 minus x. So we know y equals 10 minus x, a equals x, y. If I replace y here with 10 minus x, a equals x into bracket 10 minus x. A equals, expanding the bracket, 10x minus x squared. So now I've got a function, but the question is asking for the area inside the pen should be as large as possible. Well, that is asking for maximum area. Okay, we know when we do differentiation, if we have a function, in this case, a x to the power of n, then the a, the x, will be equal to n x to the power n minus 1. And for the second derivative, the squared a over the x squared will be equal to n into bracket n minus 1 x to the power n minus 2. That's times x to the power n minus 2. So that's the second derivative. But in this case, we want to maximize the area when we have a function. When we differentiate our function and set it to 0, which means we've got, this is the differential. In this case, the a, the x equal to 0. That means it's stationary. If we then differentiate again and it's negative, that means the squared a over the x squared is less than 0, negative. Well, that would be a maximum because your curve is going like that. So that's a maximum. As you're going up the hill, the top of the hill is 0 gradient. As you're coming down the hill, the gradient is negative, and that shows maximum. Of course, you could get minimum, and that's when the gradient, second derivative, is positive. If you have the 2a, the x squared, is greater than 0, well, then that would be a minimum. Because from 0 to positive gradient is a minimum. So you can see we got function now, and we want the maximum. If it's positive, then it will be minimum area. So this will be a maximum area, and that will be a minimum area. So here's the function. Now we're going to apply the differential processing. So if we find the a, the x, this is to power 1. 1 times 10, that's 10. X to power 1 minus 1, 0. Minus 2 times minus 1 is minus 2. X to power 2 minus 1 is 1. And then when we set that to 0, value of x here at the maximum point, that's what we want to find, the value of x, maximum or minimum. So we set that to 0 at the stationary point. Then we get 10 minus 2x equal to 0. 2x equals to 10. X equals to 5. So at the turning point, x is 5. At the turning point here, x is 5. So we need to find the 2a, the x squared, which will be, and that will be 0 times 10, that will be 0, minus 1 times 2, that would be 2, x to power 0. We know x to power 0 is 1. X to power 0 equals 1. So therefore, the 2a, the x squared equals, well, 1 times minus 2 is minus 2. So it is a maximum because it's negative. At that point, it's a maximum. So when x is 5, is the maximum. When x is 5, we need to find y. So y equals 10 minus x. So y will be 10 minus 5, which equals to 5. Therefore, y equals 5. Now the area will be equal to xy. We know x is 5 at the maximum. Area equals 5 times 5, and that will be 25 meters squared. So that's the area. So this will be, the length should be 5 and the width should be 5. So basically, a square.